So this says find f plus g of -2. So I'm going to go ahead and find g of -2 and f of -2 first, and then add them together. You can add the two functions together and then plug in -2 and get your answer. It doesn't matter which way you do it. I just preferred to do it the other way. So I'm going to find g of -2, which is -2 plus 1 or -1. And then f of -2 equals -2 squared plus 5 times -2 minus 1 or 4 minus 10 minus 1, which is -7. And then f plus g is going to be -7 plus -1 or -8. Okay, so that's the first answer. Some of you got it correct. Thank you. Second answer is just f plus g of x. So we're just adding the two functions together. So I've got x squared plus 5x minus 1 plus x plus 1. So that's x squared plus 6x. That's it. X squared plus 6x. Questions? Okay, and then on C, I'm subtracting g minus f. So that's going to be x plus 1 minus x squared plus 5x minus 1. So that's going to be -x squared minus 4x plus 2. Okay, and then on the next one, I am definitely, because it says times, instead of multiplying the two equations together, I'm actually going to find g of 6 first and then f of 6 first and multiply my answers together, because that will be easier than multiplying my two polynomials together and then substituting in 6. So I'm going to find g of 6, which is going to be 6 plus 1 or 7, and then f of 6, which is 6 squared plus 5 times 6 minus 1, 36 plus 30 minus 1. So that's going to be 65, pretty sure. And then f times g equals 455. Okay? You thought the x next to it was supposed to, the x next, in which problem? I'm not sure what you mean this x?
I didn't realize it was an f of x function. I thought it was like the...
No, yeah, if it's inside, if the x is inside a parenthesis, it's always an f of x function. And then this is telling me what I'm going to do. Add, subtract, multiply, or divide. Add, minus. It's been a long time. This was the first thing we did at the beginning of the year. Multiply. I think it was the first thing we did. Yeah. And then divide. So the divide one would be, Conrad, trust me, you're not the only one. You're not the only one. Okay? And then the last one is x squared plus 5x minus 1, which is not factorable. And then divided by x plus 1. So that's the whole answer. Done. Finished. So any questions? I know that some of you forgot how to do it. Does that bring back some memories on how to do this? Is everyone okay? So we're going to do stuff like this today, only we won't have the function notation. So we're going to do polynomial functions today, operations on polynomial functions today. So let's see. I don't know why there's a log screen. Oh, it isn't. What is a polynomial function and how do I add, subtract, multiply polynomials is what we're doing. So we have a whole bunch of vocabulary, and I just kind of put in the definitions already and put some pictures and some things that we might need to talk about before we move on. So a polynomial is a mathematical expression of one or more algebraic terms, each of which consists of a constant multiplied by one or more variables raised to a non-negative integral integral power. Okay, so polynomial, poly means many, nomials means terms. For example, numbers 1, -1, 2, -2 are also polynomials with one term. 2x plus 3 and -3x cubed plus 5x squared plus 2x minus 7 are also polynomials. So anything like that is basically a polynomial. What are not polynomials? So we have an example of not polynomials. Negative exponents, square roots, variables in the denominator, those are not polynomials. So basically polynomials have to have exponents with a positive exponent. It's a positive exponent. Okay? Nothing in the denominator, no square roots, no negatives. Any questions on that? Okay, and then the standard form basically they're in order, right, from the highest exponent to the least exponent, or to a constant. And I just said see picture above because I have some pictures for you. And then in factored form, we have an example of factored form. So it's just like a quadratic in factored form, in parentheses, although it can have many, many factors, or a few factors. Any questions on those yet? Are we okay? Okay. And then the degree, polynomials are really, you talk about the degree of the polynomial, which is really the largest exponent the variable has in a polynomial with one variable. So it gets a little more complicated to talk about the degree if they have two variables or two or more variables. We're keeping it to one variable right now. So in calculus next year, if you guys are taking calculus, you may get to more than one variable. And I know that some of the examples have more than one variable in there and they show the highest degree, such as if you look at this last one that has x squared, y cubed in it. If you combine the variables, the exponents together, you get a degree of 5, which is bigger than x to the 4th, so it's degree 5. So it's just the highest exponent is my degree. A term, it's already probably been defined for you several times. A term is either a single number or variable, or numbers and variables multiplied together. Terms are separated by a plus or minus signs, and sometimes by a divide. Not very often, though. Mostly separated by plus or minuses. Okay? Are you leaving? No. Okay, have fun. Coefficient, a number used to multiply a variable. Example, 6z means 6 times z. Z is a variable, so 6 is the coefficient. These are words that you've known for a while now. Variable with no number. A variable with a no number has a coefficient of 1. Example, x is really 1x. Great. So the next two terms are ones that we use a lot with polynomials. A leading term is a term containing the highest power of x. And the leading coefficient is the coefficient of the leading term. So you'll use those a lot, especially when we start graphing polynomials. Yay. Okay. And yes, we are graphing polynomials. Common polynomial functions, degree 0 is constant, degree 1 is linear, degree 2 is quadratic, degree 3 is cubic. 3 of those, 4 we've worked with a lot. We're going to start doing some cubics. 4 is a quartic, 5 is a quintic, and they keep going on. You don't deal with those as much this year. When you go to calculus, you'll deal with them a little bit more. And I think we're almost done with the vocabulary. We are done with the vocabulary. So that's the vocabulary for today. Now we're going to add, subtract, multiply. Okay, we are not dividing yet. That is a whole lesson by itself. So we're just going to add. It's going to be pretty easy. Add and subtract polynomials, right? We add like terms, just like we've been knowing how to do forever. So we just combine our like terms. So my like terms in this case are my x's and my constants. So I would get 6x plus 4x is 10x. And then 3 plus 5 is 8. Nice job, you guys. And then same with the next one. So the next one it's a subtract sign. So I need to make sure that I distribute my subtract sign through there. So my like terms again are the x's and then the constants. So 3x minus 2x is negative 5x, and negative 1 minus 5 is negative 6. Yep. And then we can get to the little bit bigger polynomials. And again, I've got a subtract sign, and of course I can highlight all my like terms. So I've got my squareds, and I've got my to the first powers, and then I have my constants. So I've got 5x squared minus 3x squared is 2x squared, and 7x minus 6x is x, and 2 minus a minus 2 is plus 4. Okay. Does anyone have any questions? People have been putting the answers in there as we've been going along. Awesome for you guys. Good job. So now we've got quite a few problems. So the first one, or A, is, what is A? 5x plus 1. And the second one is 18x plus 12. Please make sure if you have any questions on any of them, ask me. So 7x cubed minus 3x squared plus 6x minus 18. D should be x to the 5th plus 2x to the 3rd plus 9x squared plus 3x plus 4. Whew. E should be negative 2x to the 5th plus 3x squared minus x plus 4. And then F should be 7x to the 4th plus x to the 3rd plus 2x squared minus 3x minus 12. And then G is minus 2. Okay. Is there any questions? Are we okay? Not too bad. Adding, subtracting. I knew you guys did that. Okay. So now we're going to do pretty much the same thing as what we did for the warm-up. So I is 5x squared minus 8x minus 19. 11. Wow. 2 is x cubed plus 6x squared minus 8x minus 23. 3 is x cubed plus 2x squared minus 3x minus 1. And 4 is negative x cubed minus 2x squared plus 14x plus 12. Beautiful. Okay. Oh, sorry. That's okay. Sorry, Daniel. Are you okay with it though? Is it good? Okay. All right, so next we're going to go to distributive property. I know you guys all know how to do this, but we're going over it. So, because it's part of polynomials, right? So 2x times 5x squared is 10x cubed plus 14x. Okay, and then if I distribute a negative 1, all that does, wow, is change the sign, right? So I've got negative x squared plus 4x minus 8. Okay, and then for A, again, I'm going to distribute 9x to both terms, and I get negative 9x cubed minus 27x. Done. Please do the next 3 problems. You guys are awesome. That is not what I wanted to do. do this ACT fast, a minute per problem. I think you guys can do it. Call help desk. Fix warm. Man, I need to do all my fixie notes. Yes. Yes, yes. Oh, B. Nice job, you guys. Oh. Wow, okay. Lovely. Yep. Good job. Okay. Nice star. How'd you get that on there? Good job, you guys. Oh, wow. So while you guys are doing this, I just remembered, sorry, when you're doing your homework today, you're going to need the vocabulary we went over. You're going to need that for some of the homework today, just so you guys know that, okay? Just want you to be aware of that fact. Like 2 questions, maybe 3. So I can post. When do we need to? Well, this is in the packet. So this is all in the packet. I will have it here. Oh, sorry. I will have it here on Monday and Tuesday. So if you're coming into school on Monday and Tuesday, you can get it then. Or it's downstairs. It's downstairs right now. And it's just this unit, unfortunately. For the homework in Delta Math, yes. It's just this unit. Right now, we're just doing it a unit at a time right now because we're behind. So, I don't know if you can get it tonight. Are you going to be in the building tonight? Is the building going to be open tonight? That's the whole question. If you can't get in the building, then you can't come in and get it. So I think they're here till 3 at the front office. So, sorry. Okay, I don't know why I started this. Okay, so let's go ahead and do this. So I've got negative x to the 3rd plus x squared minus x. And then 10x to the 4th plus 30. Oh, that's not the 4th. Sorry, that's the 6th. 6th, 30x to the 5th, and then, oops, I forgot the middle, 6x to the 5th minus 3x to the 4th plus 12x to the 3rd. Any questions? Everyone okay with that? Okay. Next. Now we're going to talk about double distributive property, right? So you guys already know how to multiply binomials, but we're going to do little bigger ones because those are the ones I chose to do for my part of it. So you can distribute Or you can do, I like doing bigger ones in a little multiplication box because I like how it's organized a little better. So you can do it however you want. But this is x to the fourth times 2x times x squared, 5x, and negative 6. And then it's just a multiplication table, right? So x to the fourth times x squared is x to the sixth. X to the fourth times 5x is 5x to the fifth. X to the fourth times negative 6 is negative 6. X to the fourth. Oh, 2x times x squared is 2x to the third. 2x times 5x is 10x squared. And then 2x times negative 6 is negative 12x. Usually, like terms are on diagonals, but none of these are like terms. So this would just be, let's see, what would this just be? X to the sixth plus 5x to the fifth minus 6x to the fourth plus 2x cubed plus 10x squared minus 12x. Wow. Okay. That was huge. Okay. And then sometimes if I have a 3 by 3, I can still do the multiplication table. I'm just going to make this bigger so it gives me more room to, it feels like it gives me more room to write. I do a 3 by 3 multiplication table. Again, for me, it just helps me organize it a little better. You don't have to. You can do the distributive property 3 times. However, it's easier for you to do. Please do it that way. So I've got negative 3x to the fourth, x to the third, and 5x, x to the fourth, negative 2x, and negative 5. So negative 3x to the eighth, 6x to the fifth, 15x to the fourth, x to the seventh, negative 2x to the fourth, and negative 5x to the third. And then we've got 5x to the fifth, negative 10x squared, and negative 25x. And I think we only have a couple of like terms in here. So I've got a fourth and a fourth. And I think that was it, right? Oh, no. We've got a fifth and a fifth here. So there's my like terms. So my answer should be negative. Let's try and get a pencil. Negative 3x to the eighth plus x to the seventh plus 11x to the fifth plus 13x to the fourth minus 5x to the third minus 10x squared minus 25x. So there's my answer. Whew. Because this is what multiplying polynomials is, John. It's beautiful. And then you get ones like this, where I have a binomial times a binomial times a binomial. The easiest way to do this is multiply 2 of them together and then multiply that answer times the third one. So I'm just going to multiply these first 2 together, right? Just using the FOIL method. So x times x is x squared. X times negative 1 is negative 1x plus 4x minus 4. So I get x squared plus 3x minus 4 times x minus 6. And again, I can do the FOIL method again, or I could do the box, whichever you want to do. So it would be this times this, and this times that, and this times that. So So x squared times x is x cubed. And x squared times negative 6 is negative 6x squared. And 3x times x is 3x squared. And 3x times negative 6 is negative 18x. And negative 4 times x is negative 4x. And negative 4 times negative 6 is 24. Now combine my like terms together and I get x cubed minus 3x squared minus 22x plus 24. Whew. Questions? Nice job, Lewis. Okay, now it's your turn. I've got 7 of them here. I'm just going to go ahead and put the answers in, and then if you need me to go over one of them, I will. So here we go. So A is, let's see, what is A? 5x squared minus 7x minus 6. B is x cubed plus 3x squared minus 7x minus 6. C is 4x to the 6th minus 13x to the 5th plus 9x to the 4th plus 8x cubed minus 14x squared minus 9x. Whew, okay. D is negative x to the 7th minus 3x to the 6th minus 6x to the 5th minus 8x to the 4th plus 6x squared plus 6x plus 24. Sorry, that's where I ran out of paper. E is x to the 3rd plus 14x squared plus 51x plus 54. F would be 3x to the 4th plus 7x cubed plus x squared minus 7x minus 4. And then G is negative 56 x cubed plus 166x squared minus 118x plus 20. Whew. Does anybody have any questions? Are you okay with that? I didn't give you this many problems on your homework, but there are some 3x3s. No, this many to multiply out. But altogether, I think there's a total of 17, add, subtract, multiply, divide, and then some vocabulary type questions. Okay? So you're going to just spend the rest of the time working on that. You have about 25 minutes. You